Okay, let's go back to Chapter 8, and we're going to start Chapter 8 in 8-1 doing factors in GCF, greatest common factor. For the most part, this should be a review. Please take notes to get that muscle memory back of splitting these numbers into their prime factors, and then we're going to apply this to basically the reverse of FOIL later in the chapter. So let's start first by looking at factors. And in example 1, we need to find the prime factorization. The prime factorization is a number written using only prime numbers. So last year, we practiced two ways. We practiced the ladder and the tree. I'm going to use the ladder because I think that's the one that you're probably going to remember, but the tree I think you definitely will. 40, there is a factor of 2. That's prime. 40 divided by 2 leaves me 20. There's another factor of 2. 20 divided by 2 is 10. There's another factor of 2. 10 divided by 2 is 5. And the only factor that's left is 5. If you remember, the ladder has to end with the number 1 at the bottom. So the prime factorization of 40 is 2. And I have 1, 2, 3 of them, so I can write it as 2 to the third times 5. And that would be the prime factorization for 40. Let's do the prime factorization of 33. 33 does not have a factor of 2. It does have a factor of 3. Leaves me with 11. And 11 is prime, so I'm going to divide it by itself to end my ladder with a 1. So the prime factorization of 33 is 3 times 11. Let's do one more, 49. 49 does not have a factor of 2 or 3 or 4 or 5 or 6. It does have a factor of 7. Leaves me with 7. 7 is prime, so I'm going to divide it by itself, end my ladder with a 1. And the prime factorization of 49 is 7 times 7, or 7 squared. Okay, the exponents aren't going away. In example 2 now, we need to find the greatest common factor, or GCF. In order to do that, you need the prime factors of each number. So let's find the prime factors of 100. There's a factor of 2, which leaves me 50. Another factor of 2, I'm left with 25. The only other factor that's left is a 5. Divide 5 by itself, end it with a 1. The prime factors of 100 are 2. Now this time I'm going to write it out separately. 2 times 2 times 5 times 5. And you'll find out why in a second. For 60, let's do the same thing. I haven't done a tree yet. I'll show you or remind you what the tree is. That would be 6 and 10. 6 splits. Those are prime. 10 splits, and both of those are prime. So 60 is 2 times 2 times 3 times 5. Now the GCF is everything that's in common. So I have a 2 in common, another 2 in common, and I have a 5 in common. So the GCF of 160 is 2 times 2 times 5. Okay, they have 2 2's in common and 1 5 in common. 2 times 2 gives me 4, times 5 is 20. That means my greatest common factor is 20. Let's try another one. The greatest common factor of 26 and 52. 26 divided by 2 is 13. 13 is prime, divided by itself, so I end with a 1. That means 26, the prime factorization is 2 times 13. 52 has a factor of 2, and that goes in 2 times 26. Has a factor of 2, leaves me with 13, divided by 13, and I've got a 1. Hopefully this whole process is coming back to you. 52, the prime factorization is 2 times 2 times 13. Now we check and find what's in common. There's a 2 in common and a 13 in common. That means my greatest common factor is 2 times 13, which is 26. Some of you may have noticed from the very beginning, 26 and 52, that 26 times 2 is 52. That would also make it the greatest common factor. Now, let's apply it to our algebra part. Let's find the greatest common factorization of monomials. Greatest common factor, sorry. So 3x squared, there's a 3, and then there's 1, 2, 3 x's. 6, I need to break it into its prime factors, which is 2 times 3. So 2 times 3 times, I have 2 x's. There's a 3 in common, there's an x in common, and there's another x in common, which means my greatest common factor between 3x cubed and 6x squared is 3x. I have 2 of them, x squared. Okay, so now we're doing it with monomials. It means we're going to have a coefficient and we're going to have a variable. Let's try the next one, 8x and 7y squared. 8 splits into 2 and 4, which splits again. So I have 2 times 2 times 2 times, I have 1x. 7 is already prime, 7, and then I have 3 y's. Okay, there's nothing in common. When there is no number in common and no variable in common, there's only one thing they have in common, and that's the number 1. Occasionally, you're going to get questions where there is nothing, no factor in common. When that happens, it's not no solution, it's just 1. Let's try one more. 18g squared and a 27g to the third. 18 is too big for me to just do it in my head, so let's set up the prime factorization. So 18g squared is 2 times 3 times 3, and then I have 2 g's. 27, let's do the tree. 27 is 3 times 9. That's prime, 9 splits. So that is a 3 times 3 times 3 times g times g times g. 3 in common, 3 in common, and 2 g's in common. That's 3 times g times g. 3 times 3 is 9, g times g, g squared. Okay, hopefully some of you are starting to notice that you can use the exponents to figure it out. If I have 2 g's in my first term and 3 g's in my second term, the greatest common factor is going to be g squared. And then the coefficients 18 and 27, you have to break it down to figure out what the greatest common factor is. All right, it's your turn. In the book, please do number 1, number 9, number 13, and number 18. Bring your work tomorrow. I want to check it, and then we'll practice more with 8-1 before we move on with the rest of the chapter. Thanks, everyone. Good night. I'll see you tomorrow.